All right, so again, make sure you have your Cornell note template created and you're ready to go with the notes. Today's date is January 7th, 2015. The topic we're going to discuss is inequalities. The objective is we're going to be using inequalities to determine constraints and constants, and we're going to solve expressions and equations. The essential question you want to keep in mind is how can you use inequalities to determine constants and constraints? Using inequalities to describe quantities. That's going to be the first section of our notes. So you can use inequality symbols with variables to describe quantities that can have many values. So this is something that we discussed prior to the Christmas break, the holiday break. So this should be like a quick refresher. We're already familiar with the less than symbol and the greater than symbol. And some words that are associated are fewer than, or below, or more than, or above. And then there's two new symbols that we discussed, which were less than or equal to, because of that little line underneath it. And then we have greater than or equal to, again, with the little line under it. And some words associated with less than or equal to, at most, or no more than. And some words that are associated to greater than or equal to, at least, or no less than. So here's some examples of what that would look like when you read it in a word problem. Less than or equal to, it can be read as Lisa can lift no more than 25 pounds. So that means she can lift 25 pounds, but then once you get to 26, she cannot lift it anymore. So that's why we can include 25 pounds and everything underneath, because she can lift 24, she can lift 20 pounds, 5 pounds. So because it says no more than 25 pounds, you want to include it and then every number underneath. That's why it's less than or equal to. So another phrase to help you remember how to read greater than or equal to. Pete wants to take at least $12 to the basketball game. So that means he wants to take $12, and if he can get more out of his mom and dad, he probably won't argue, right? So that means we want to include $12, or let's say his mom's feeling generous and she gives him $15. He's going to be okay with that. So that's why we want to say include 12, so that's why it's greater than or equal to. So at least $12 or more. Graphing the solutions of an inequality. So now we have a solution for an inequality are the possible answers it could be. And the solution of an inequality means it contains a variable and it can be any value as long as it makes the inequality statement true. That's huge right there. It has to make it true. So if a number makes the inequality true, then it's a possible answer. It's a possible solution. So for example, we have x is greater than negative 2. So that means x has to be a number that is larger or greater than negative 2. How we would graph the solutions or the possible answers on a number line, since we're not including negative 2, because negative 2 is not greater than negative 2. Negative 2 is equal. Since it doesn't have the little line underneath, we're not going to include negative 2 as an answer, because it would not make this statement here true. So to show that on a number line, we would actually put an open circle, and then we would shade in everything that is greater than negative 2. This open circle here tells us that we're not including negative 2. That negative 2 is not a solution. But everything else that we shade in on our number line is a possible solution. So this is what the graph would look like for this inequality. X is greater than -2. Let's look at here. 5 is greater than or equal to y. So again, this tells me that 5 is going to be larger or equal to whatever the letter y can be. So y can be 5 or anything larger than 5. I'm sorry, anything smaller than 5, because 5 is going to be greater than or equal to this number. So to show that on our number line, we want to include 5 because it says greater than or equal to. So to show that we're including 5, we're going to put a solid circle. So here we have an open circle because we're not including -2. But since we can include 5, we're going to have a solid or shaded in circle. And then on our number line, we're going to shade in everything that is less than 5. Because again, to make this inequality true, this number for y has to be either equal to or less than 5. So here's the graph that shows this inequality. Now we're going to talk about how to solve addition and subtraction inequalities. It's very similar to when we're solving variables for regular equations. But instead of having just one specific answer, we're going to have many different variables, answers for our variable. So here we have x plus 5 is less than -12. So we want to isolate our variable, and we're going to do the inverse operation of addition. Since that is what's happening in our problem, x is being added to 5. We're going to do the inverse operation, which is subtraction. So we're going to subtract 5 from both sides of our inequality. And now we have x is less than -17. So the solution for x can be any number that is less than -17. So here I graphed our solution. As you can see, we have an open circle because we're not including 17. The answer has to be less than 17. So since we're not including it, we're not going to shade it. We're just going to put an open circle. And then we're going to shade in our number line everything that is less than -17, which is going to the left of -17. So let's check our solution. So we can literally pick any number on our number line that is less than -17 and see if that makes our inequality true. So let's pick -21. Is -21 less than -17? Well, let's put that number or that solution into our inequality. So instead of having an x, I'm going to put -21 plus 5 is less than -12. -21 plus 5 equals -16. Is -16 less than -12? Yes, that statement is true, so that means our solution is correct. Let's try a subtraction problem. 8 is less than or equal to y minus 3. So since our variable is being subtracted by 3, we're going to add 3 to both sides of our inequality, and we're left with 11 is less than or equal to y. So the solution is equal to 11 or any number greater than 11. Since our problem says that 11 has to be less than or equal to our y. So what that looks like graphed is, since we have or equal to, we're going to have a shaded circle on 11, and then we're going to have every number that is greater than 11. So to check our solution, let's just pick a number that's larger than 11. Let's go with 13. Is 13 equal to or greater than 11? Well, let's substitute 13 for our variable. So now we have 8 is less than or equal to 13 minus 3. 13 minus 3 equals 10. Is 8 less than or equal to 10? Yes, 8 is less than 10, so that makes our statement true. So that means our solution is correct. Now let's talk about solving multiplication and division inequalities using the same concept. Again, we're looking at inverse operations. So let's look at multiplying first. We have 12 times x is less than 24. So since our variable is being multiplied to 12, we're going to do the inverse operation, which is division. So we're going to divide by 12. So 12 divided by 12 equals 1, and 1 times x is x, and then 24 divided by 12 is 2. So since 1 times x is x, and 24 divided by 12 is 2, our answer is x is less than 2. So if we want to graph our solution, again, we're not going to include 2 because x has to be less than 2. So that means our graph is going to have an open circle on 2, and then we're going to shade everything to the left of 2 since it has to be less than 2. To check your solution, pick a number that's less than 2. Let's go with -1. So we're going to substitute -1 in our variable. So we have 12 times -1, which equals -12. Is -12 less than 24? Yes. So this makes our statement true, so our solution is correct. Please notice I'm substituting a number from our number line back into our original problem, which was 12 times x is less than 24. So now let's look at division. We have y divided by 3 is greater than or equal to 5. So the inverse operation for division is multiplication. So that means we're going to multiply both sides by 3. And when you cross cancel out or the 3's, you have 1 over 1, which equals 1 times y. So that leaves us with y. And if we multiply by 3 on one side of our inequality, we have to multiply 3 to the other side. So 5 times 3 is 15. So that leaves us with y is greater than or equal to 15. So now we're going to graph our solution. And since we're going to include 15, because y can be equal to 15 or greater than, on our number line, we're going to have a shaded circle for 15, and then everything that is greater than 15. Since y can be greater than or equal to 15. To check our solution, you can pick any number that is either 15 or bigger than 15. Let's go with 18. So I'm going to substitute 18 back in our original problem, which was from up here. So 18 divided by 3 is 6. And is 6 greater than or equal to 5? Yes. So that means our statement is true, so our solution is correct. Please make sure if you need to go back over the video, you rewatch the video and make sure that you are working out all your problems in your Cornell notes. And if you have any questions, make sure you write those in the question section of your Cornell notes.